Yeah, this talk is just about kind of how I personally test APIs, .NET APIs in specifically, and kind of more my journey of like figuring out how best to test APIs in general, really. So this is a bit of information about me. Most people know me. I run 2 .NET groups, so this one and one in York. I'm also a MongoDB champion, MVP, Microsoft MVP as well, and I work at a company called Cresgo, and I work on the API team at Cresgo, which build our partner APIs. So tonight we're going to talk about a bit about testing, the confidence testing gives us, the different types of testing, about mocking, how we can layer our tests up to make them more composable, and also different kind of production dependencies and how we can utilize them in our tests, and then different technology choices and how they can make an impact on testing as well. So you're probably thinking, why should I trust you? And you probably shouldn't, right? Like I've done like loads of mistakes like in software development. I've written loads of buggy code. Like, to be fair, like before I started writing tests, I thought I was actually an amazing software developer, and then like I'd start writing tests around my stuff, and I realized I was just garbage. But most of the time I'm just an engineer, like probably the rest of you in this room, and I'm just trying to get my job done at a higher quality, so I don't end up with like bugs and like issues with production issues from like clients, etc., which gives the clients more confidence that our software is going to work. And I've taken, as I said, I've taken lots of bad choices, especially with like different ways of testing as well. So how my like learning curve for testing has been like a bit of a hill, and then a fall and a hill. But then I've just learned things along the way as well. And also I've talked to lots of people about how they've been testing things. I had lots of conversations about testing because I'm quite like, I really enjoy testing. And I find it's like one of my main jobs as a software developer to just write code, like test code. I think it's more important than writing really good structured production code, to be fair. And to be fair, these are just my learning experiences, so you might not take away anything from this talk, you might take away something. It's kind of up to you, or you might want to talk to me afterwards and just tell me that I'm stupid and that you're totally right about how you test. But for me, like tests are not about doing the perfect solution, it's about more gaining confidence. So like I said, I don't know how I've ever written bug-free code before tests, because like the amount of times that I've caught like little kind of subtle like logic issues or things which I didn't think about before I started writing my tests, or kind of expanded my knowledge of how what something should behave like by writing tests, is kind of like I gain more confidence in that. But I still probably have bugs in code. The company I work for at the moment, we've probably shipped things with like bugs in it because we didn't understand like certain things, because we didn't understand how like a third-party service like responds back to us, and we've carried around certain things which didn't exist and it worked a different way. So then we deployed it and then it just worked a completely different way and just made our code break. Or we've like assumed like a upstream service does something in a certain way and sends us messages in a certain way, but instead it sends us loads of the same message, then we never counter for that kind of thing. So things like non-functional testing has been counted for in our tests as well. But it also helps like myself as well, kind of like understand what our code is supposed to do. So after a month, I've pretty much forgot what I'd written a month ago. So it's quite good to just go into the test and see what the behavior is supposed to be like for like maybe a given API endpoint, and see what kind of like response it's supposed to get. Or maybe you get like a issue from a customer come in and they're like, oh, we've hit your API like this and we expect this response back, but it's giving us this other response. And if you can go in your tests and just look at like what it's supposed to behave like, you can go back to them and say like, oh no, it's not supposed to do that. Or we didn't think about that scenario, and then write into your tests. So then you can understand your behavioral code better. And another thing with I find with testing is there's lots of kind of terminology for it, and I really hate this. So people call them like back-end tests, interactive tests, usability tests, integration tests, system tests, acceptance tests, regression tests, performance tests, functional tests, unit tests. Like there's like people always use all these like terms interchangeably, and it's really, I find it quite annoying, because like if you go into the Microsoft website, like they call certain things integration tests, and you talk to other people, they call them developer tests, and then other people call the same thing functional tests or boundary tests. And yeah, it's kind of, there's no really good terminology for testing. So it's quite confusing when people talk about things because you have to kind of elaborate quite a lot about what you're supposed to be doing. So usually my tests kind of look a bit like this. So I have like functional tests, and I've got lots of them. I've got unit tests, and I've got a really small amount of unit tests in my code. And then I've got like a fair amount of end-to-end tests covering like an end-to-end flow of something. And this has changed quite a lot from like when I first started doing testing. I pretty much wrote 0 functional tests, and I'll talk about what I mean by functional tests as well later. And then I wrote like loads of unit tests, like tons, like probably like twice the size of that circle for functional tests, just to try to cover every single scenario. And then maybe had like about the same end-to-end tests. But that's kind of shifted quite a lot with like kind of like how I understand like a better ways to test in my own physical code to make it so they're less buggy, we ship something of better quality. But your solution for yourself might be a little bit more like this, where you've got like probably equal functional tests to unit tests. But it depends like kind of what you're working on. There's no kind of like one scenario fits all. And I think that's kind of another problem where you have to kind of use your brain to think like what you want to achieve, and then write the tests around that to kind of achieve that and make sure you've got a higher confidence that things are going to work. So this is a bit of a diagram of kind of like the testing strategies what I talked about: functional testing, unit testing, and N10 testing. So normally we have like a service. This is our service in the middle. And our service, we're going to call it an insurance API. And that insurance API technically is just a bunch of functions, right? In programming, everything is just a function, and a service is just a ton of functions, really. And then functions probably talk to a database, maybe 1 or 2 of them talk to a database, maybe more. And then also a function might talk to an outside third-party API as well. And then also you might get some requests into this API from maybe some external like partner, or maybe internal kind of like communications between services. So you might get some gets, some posts, and then also you might get some messages off message bus as well. So this is kind of like what maybe, pretty much what our services look like at our work currently. And then you might have lots of other different services as well. So these might also talk over a message bus or over HTTP. And then we've got like a claim service. So we've got these 2 services, an insurance API and a claim service behind the scenes. And when we test these things, a functional test is testing all the behavior which are given single services, how it's behaving. So everything coming in from the get, the post, the messages, and anything which then it exposes, like they get to another external system, a post, but we're not calling the external system. We'll kind of like create that as a boundary. And then the same thing for like third-party APIs, we'll kind of create that as a boundary as well. But then things like the data which it owns, we'll test that as well as like a whole, like kind of whole functional part. And then a unit test is just usually a single like function, or it could actually be multiple functions. So it doesn't have to be like a single specific function run a single class. You might have some behavior which is exposed somehow, which covers 3 functions or 4 or maybe 10 functions. And you want to do some detailed testing on that. And then end-to-end testing is pretty much everything what it needs to communicate to do some like end-to-end flows across the whole system to prove everything is like operational, things can communicate to each other, all the deployments went okay, etc. So as I said, functional testing, these usually run like for us on every commit. So every commit what you do on our branch, either on master or a feature branch, they're going to be built and then kind of run on the build server. So we know that every single time we're not breaking things. It's tested from the entry point of the API or service. So anything what it comes into that service, we're going to like do the same calls as what somebody's actually communicating to us. So we'll craft the same message, craft the same get or the post, so it behaves exactly the same. It's going to be the boundary context or the service. So for this, it's just the insurance API. And then any external dependencies which we don't control ourselves, we're going to mock. So that's like the third-party API. We'll just mock that out and pretend how it's going to work based on its like kind of contract and the documentation. And then other things like the data, we call these like real boundary-owned services. So the boundary actually owns the data in that database. So we're going to test that as well and make sure it's actually stored as we expect it to be stored. And these could be things like SQL Server. So that something's added to the table properly. In Mongo, we've got a document there. Maybe Redis has got like some data. Well, we might use that for caching. So we'll expect to like cache results we come back from Redis, and we'll kind of like make sure they're running. Or maybe it's some kind of like Azure service as well. So for boundary-owned services, like at the moment we're using just Docker with Docker Compose. So this makes it really easy to just like spin up the dependencies of that service. So if you need like Redis, Mongo, or SQL Server, you can just create a Docker Compose file, spin that up locally, and it'll run exactly the same as on the build server. But there's other like solutions out there. There's test containers where you can create code which actually just spins up a container. And there's also like .NET Expire, which does exactly the same thing, but it's also just writing code. So yeah, easy to run on the build server. You can treat them as totally disposable as well, because your test should be completely isolated. So one test shouldn't rely on another test, and all your tests should just set up the data from fresh every single time. And if you want to make them run faster, you can use like the temp file system mounts as well in Docker, because you don't really care about the data. So if it crashes or something, you don't really care that the data still exists. So Docker Compose looks like this, if I'm maybe not seen this before. It's just a YAML file, how you declaratively declare all your services. So for example, this has got, if I can use this, ooh, I can. So this has got like a Mongo instance of the service, which is exposing these ports, and it's also got like a SQL Server edge instance, which is exposing some ports and has some environment variables to it as well. So going on, that's pretty much like kind of like more, I suppose, theory kind of side of like how I kind of do testing, but more the practical side of like how we code it is a bit different. So in .NET, there's a thing called Web Application Factory, which is part of the ASP core testing packages. And it allows you to test your APIs as if you're hosting it in like on a web server somewhere else in Kestrel. So it does is kind of swap out Kestrel and sticks in a test server. And that means it just behaves exactly the same, but it's just faster because it's all just in memory. And before the Web Application Factory, I used to actually spin up an instance of IS Express and then poke it manually. But this allows you to reconfigure it every single time, which is a bit more helpful. So yeah, it's based on a NuGet package, what you can just pull into your project. You can reconfigure the test server every single time a test runs. So maybe you want to swap out some dependencies, or kind of reconfigure like how the config's set. You can do that while all your tests are running, and also monitor things and get pingbacks as well. And if you use the HTTP client, it just exposes a HTTP client to you, so you just call it the same as if you're calling like a third-party API or an API internally. So normally when you create these, you can just create an instance of the Web Application Factory of a type T, so it's a generic, and pass in your program CS. But I usually kind of create an instance of it, like, well, inherit a class from it, sorry, and just use that as like the base configuration for my testing. So for example, this is the Insurance API application factory, and this has some extra stuff in here to reconfigure the IOC container. So it adds a mock bureau client and swaps out the iBureau client to use the mock bureau client when it reconfigures itself when it starts up. So anything what you want to have your default configuration for how you want your test to run against your web server, you can just like inherit from a Web Application Factory and then create that every single time. The Web Application Factory has a bunch of other kind of like methods you can override. So it's got like get test assemblies, so the things which scanning for like setting things up. You can reconfigure that so it's not just scanning the assembly for your application. You can scan other things. You can reconfigure the HTTP client. So maybe you want to put some extra headers on the HTTP client every time you get it back. So maybe you got some authentication keys or expect like the language header for certain things in your application. You might want to set them by default. You can also kind of change how the host builder is built. You can change how the host is created, how the test server is created. So you can change a bunch of extra things really. So it's quite configurable. So in our work with our Blazor stuff, we actually host like an API inside of the Blazor and makes them both talk together as well. So you can do that as well. So then it's actually hosted on the port instead of just the test server. So then we usually then create like a factory, and then from that factory you can get a HTTP client from it by calling create client. And then we can call post on that client with to go post to the quotes endpoint, for example. And we can pass a string content into it with just some JSON. And then we can get the content back and read it back out as a JSON document and then do some assertions on it. But Web Application Factory can be reconfigured, like I said. So you might have your base configuration, which you have inherited from your Web Application Factory as like your own instance. But then you can take that factory and call with host builder. And then you can then set extra things. So maybe you want to swap like a feature flag out. You can use the use settings method to swap food to be a bar value. Or you can just swap the services out as well. So maybe you want like, I don't know, you turned all your hosted services to not start. And then you want to then add your hosted service in to test that functionality in a given one test. You can do things like that. You can also then swap out the authentication mechanism as well. So if you haven't got like some kind of authentication scheme which you kind of care about that much, maybe you're just using like an API key and everybody has the same default permissions, you can just like mock that out and create a test handler. So you can say like all requests going through are just authenticated, and then you can just pass in extra claims and stuff like that. Or you can extend this to then read different headers to like swap different values if you want to kind of add different claims to your principal as well. So normally with a lot of tests as well, you end up with like having to like copy and paste loads and loads of code everywhere. And I've seen it in like tons of code bases where the same code is repeated over and over and over again. And even to the point where you've got like things like where you're reconfiguring something. Maybe you want to like enable feature A because you want to be able to test that before you deploy it and it's turned off in production, but you want to keep writing tests around it. You might want to encapsulate that into something else. And we encapsulate them into harnesses, which is just another class. And it's just a way to kind of share that code. So for example, we've got a harness here, which just encapsulates a web application factory. So that thing what we built before. And the first thing we want to encapsulate is probably like post and a quote. So instead of us writing the create the client, go do the post, go get the content, return it back out, and then do our insertions, we're doing that code again and again and again. So we're just going to create a method called post quote, which takes in a JSON node, so the body of the actual JSON, what we want to send to the service. And then it gets back out the status code and the content, so then we can do some assertions on that. And then anywhere, if we ever change how that post endpoint works, or maybe we add extra parameters onto it, what we are required or whatever, we can just change them in one place. And then we also might want to kind of like add in different methods onto the harness as well. So for example, this has got like a international credit score calculator feature. And we can just call, and that's just set by this feature toggles.internal credit score calculation, setting a settings file variable to true. And it does encapsulate that behavior, so we don't have to keep repeating ourselves again and again and having to understand what setting that feature does, that flag in the config does. It just is quite self-explanatory. Also, if you've got like, usually if you're enabling like feature flags as well, you might want to swap out different dependencies for things to behave in different ways as well. And then also if you want to like disable kind of a message bus running, so maybe you've got some background service workers as well using hosted services, you can just remove them all out the kind of like, or enable them all, depending on which way you want to do, by just reconfiguring the service in the ISC container as well. Which also means like once we got like one harness, it's going to grow really big, to be fair. So you're just going to get the same problem just in another class. And we try to layer these up into other harnesses and give them more descriptive names. So for example, we might be storing stuff in Mongo and for the service, so we create a MongoDB harness and pass this current harness into it, so it's got access to the services it can provide. And then you might have a bureau service, so if you've got a third-party API for bureau data, maybe Experian or something, you can then create a harness around that, so other behaviors, what you want it to interact like, you can encapsulate that all in its own harness as well. And then within them harnesses, you might want to create like things which are like known bits of data. So for example, this bureau harness, I don't know if people can see, has like things which are good bureau data and bad bureau data. So if you got like a good credit score, for example, we know what that good value looks like and also know what that bad value looks like. And then we can also start adding methods to this harness to add data to that like third-party API, mocked API, and give them meaningful names as well. So you can say, go add the good bureau data for this applicant, or go add this bad bureau data for this applicant. So we've got nice and descriptive like kind of like methods to know what it actually does, instead of just like hard coding new bureau data with 700, what's 700, who knows? So it nicely encapsulates all that kind of stuff. And then also mocking, I find like mocking these days is like the least common thing what I do. So I try to avoid it at all costs. So things like mock and substitute, fake it easy, I just never use anymore. I find it much easier to just like roll my own classes and just inherit from some interface, implement some interface which has been exposed. Mostly because like if you create like things which use mock and then substitute, you create a much higher maintenance for things like what you have to change across your code base instead of just being encapsulated in one place. And hand rolling your own means you can actually create methods on your mock that make sense, right? So things like if you're using MOQ mock, you have to do .setup, .returns, and maybe a .callback, and then go capture that value somewhere else, and then they get a reference to it and do all this kind of crazy stuff, when we can just like create a class and it could just have some state itself and have some methods which actually make sense for your kind of scenario. And so for example, we've got a iBureau client which has a method called getBureau async, which given a first name and last name, it goes and looks up your bureau file. And probably in real life need your address and your date of birth and other things, but for the moment, first name and last name will do. It fits on this slide. And then it returns you back a result. But also we've added some extra kind of methods on here as well called add bureau data. And we can say, go add bureau data to this mock. And it's much more descriptive than doing .setup, .returns, and then doing that every single time in your test. And then that comes on to like setup data. So when we're actually like having to set data up for our tests, we want to be able to like pretty much skim read it. So like most of like setup data I've seen just get repeated again and again in tests, about 100 lines each time. And then you have that across multiple tests. So you end up with like about 10,000 lines of code, which is mostly just like setup data, which is the same code again and again. And it's great if you've got Copilot because you can just like tab it in every single time, but it's not that great if you go back and try to rewrite it. So I usually try to, most of the time I use records these days. So we try to create a class which is got information about kind of how we want to kind of structure our kind of setup data. So for example, this has got a quotes resource representations. So representations what we're going to send to our API for our tests. We've got like some knowledge about what a successful quote looks like. So for example, this has got a static successful quote, which passes no ID in it because you don't need an ID when you're creating a quote. You've got your applicant data, which has got your first name, last name, your date of birth, the from date for the actual quote, and the duration as well, and it doesn't have a result back out from it. But that means we've got like a successful quote we can keep grabbing every single time within our tests, and we know what a successful quote looks like. And maybe we might change like something at some point saying like, maybe the date of birth has to be in a certain range, so 1980 isn't a successful quote anymore. So you can just go back in here and change to 1970, and that might be a successful quote. But that means we can also layer these up. And so to get an invalid quote, for example, we can just go get a successful quote and change the from date to be the yesterday, which will be invalid. So we can start building up like invalid quotes from our successful quote by just keep swapping different variables in that. I also do, so with records, I do like kind of this way. And then if we just got classes and other kind of like things where with can't be used, we use like more of a builder pattern where we got builders of builders for like more complex types as well. And then when we're dealing with JSON data for our tests, we don't use like the serializers built into .NET. So things like the system text JSON serializer or Newtonsoft JSON serializer. And the reason why this is because we want to test that our contracts are what we say they are. So when we send some data to our API, we will expect it to be in a certain format, and we don't want to rely on any kind of serialization stuff within .NET to do that for us. And to be fair, I've been caught out with this loads of times with tests where people get the same model which they use for the model binding in ASP.NET Core, just serialize that and just throw it to the test server and expect it to the side. Somebody's come in and just renamed like first name to be just name, and then they deployed it. Tests are still running great. Everybody thinks everything's perfectly fine. And then the customer comes to us like, this blows up when we now call your API, saying that like name is required. And we're like, huh? And it happens quite regularly. And people I've talked to as well have had exactly the same problem. So trying to just hand-roll your own requests using like things like JSON node and hand-roll your assertions using JSON documents just kind of like ensures that you're sticking to your contracts. And if you do change your models, your tests will just blow up straight away. You won't even get past like your testing stage and your build pipeline. So this is kind of like one of the builders looks like. So we usually use the same types for actually building up the data. So for example, what you've seen with a quote, this quote resource representation is one what we'll use on the API side as well. But we'll take that and create the structure of the JSON ourselves. So we'll get the from date and explicitly say that it's going to look like this as a string. We'll take the duration and put it in as the JSON as well and the applicant as well. So that means like if we ever rename any of these, we'll know straight away in that test. And the same thing for the assertions. It looks a bit messy, this one. So we'll take the JSON document and something to compare it against. And then we'll just kind of get all the properties and kind of traverse the JSON ourselves and assert that everything is as we expect it to be in the JSON. So we're not just comparing an object which has just been deserialized. We're actually being very specific about what we're kind of testing and properties we're checking. And people normally complain like this is kind of like a lot of hard work to kind of write all this stuff. But if you've got like Copilot or you just log on to ChatGPT, it'll just write this for you. Like once you've written the first 2 lines, you just tab the rest of it in and it'll do it all for you anyway. And then test isolation. So everybody wants a test to run really fast. So you want your test to be isolated as possible, so then you can parallelize them all. So you don't want one test to be sharing the other test's data. So if you've got like a multi-tenanted system, the best way to do this is just to create a new tenant every single time your test runs. So then that is actually just completely isolated for each test run. And creating like a new like tenant with most systems these days is pretty fast. It's just usually a GUID. So then you can parallelize them all. They don't cross over each other. You're not relying on each other's data, or any kind of setup data is going to like conflict with each other. And then I guess the second best way is to create a new database. So if you use like a more flexible database like Mongo, you can literally create a new database as a GUID every single time you do a test run, and then just destroy it afterwards. So that's kind of one of the best things. But yeah, people like always complain about the test runs running really slow, and one of the main things is they're not parallelized. So just make sure you isolate your tests. And that brings me to like expressive tests. So tests should actually just pretty much be able to skim read like what they're doing, right? So after we've done all these kind of patterns, what we just mentioned a moment ago, we should be able to like kind of write a test like this. So this is using X unit with the fact on top of it. And we've got like a method name which says should return 200 with success with a response body of decline for bad bureau data. So this goes and gets a successful quote from our quote representations. We go to our harness with our bureau harness and call the add bad bureau data, passing the applicant into it. So it sets that up for us. We can go post the quote, and we've got our JSON node quote builder, and we just build the actual JSON representation from that quote, or we just constructed. And then we can check the status code is OK, and then we can just go to our assertions and assert that the body is correct based on the quote, and we're in a declined state from when it's being returned. So it's pretty much 1, 2, 3, 4, 5 lines of code, and that's pretty much just says exactly what that like test and behavior is for that scenario. So libraries and technologies. So one of the bad things about like .NET, it's got like lots and lots of libraries, and A lot of them are really, really hard to test, or they don't have interfaces on them, so you can't mock out certain boundaries. Maybe you've got a third-party SDK, what you're pulling in, and you can't test it, so you have to wrap it up yourself. But there's lots of testing frameworks, lots of frameworks which actually have really good testing kind of abilities around them. So one we've just seen, which is ASP Core. Mass Transit has one as well, which creates instead of using RabbitMQ or Azure Service Bus, you can start. You can just say use the in-memory test harness for it, and then that kind of sets up all the in-memory bus, for example, and then you can wait on messages be delivered, wait for messages be consumed. You've got pretty much it's built up similar to this pattern with harnesses, where you go grab a harness and say, go check the harness has consumed this X message. And then also for kind of spinning your boundary-owned services, there's different databases and technologies which also allow a lot more higher flexibility to do that. So things like Mongo, RabbitMQ, Redis, they're much easier to just spin up with Docker than other technologies out there. So just make sure you kind of check out, instead of just going to the default kind of technology when you start building something, pick something which is going to be easy to be testable, because then you're going to have more confidence that your software is going to work. So I've got a little demo of the functional testing, what we've been talking about. So let me get rid of this. So we've got it's an insurance API. This insurance API is just a minimal APIs project. Can people see that? So it creates a web application, adds a bunch of services into it to do different things, adds the bureau service, and then maps some quote endpoints. In here, we're just mapping one quote endpoint, which is the post quote, which we've seen on the slides. We just get the date from the date provider, and then we can go try to create a quote. So this has got a domain kind of object where we pass it, go create something from some data. And this goes and checks some conditions of how we can create a quote based on different scenarios. So if the duration for the quote is less than 0, then it's invalid. If it's greater than a year, then it's also invalid. And then that just goes to the bureau, gets the bureau data, and then checks that successful when you get that data back, and then just calculates the quote, and then adds it to the database, and then just returns the quote in the API response. But the kind of more important thing, what we want to talk about, is the tests. So the tests are up here. Yeah, I can't. Why is that not? That's so weird. It's not in the same. Has anybody had any problems with Rider recently? All my colors keep disappearing. It's really annoying. And then none of the IntelliSense works, and then it just dies after you start it. So yes, so we have a test up here in quotation. So normally I kind of segregate the test by the functionality, so feature folder it. So we've got our post quote test here, and this has lots of tests, which are kind of how we talked about. So we've got a test where it should return 400 bad requests for a from date in the past. So we get a successful quote, we change the from date so it's in the past, we post the data, and we expect a bad request. And then we've got the same thing for the duration being out of range, so maybe the quote's not long enough or too long. We also get bad requests for that. We can also then check a successful quote, but with no matching bureau data, because we're not setting up the bureau data here. We post that, we get we can go to this assertion thing now, we get a response back as a document, and check that. The same thing for, it's stored. So now we're checking that it's stored inside of our Mongo database as well. So after we post it as a successful quote, but it's got no bureau data, we go check in Mongo that we've got that ID, and then we do exactly the same thing for the assertions for Mongo. So similar to the JSON assertions using JSON document, we just take a BSON document and just check that all the structure of that BSON document is exactly in the database as we expect it to be, because that's pretty much another contract. So that checks all that. And then we've got another test for saying like if we got bad bureau data for a successful quote, it's going to come back as declined. A referred quote with good bureau data is then just referred. A declined quote with good bureau data is declined, etc. So as you see, like these tests are pretty much just the same, just adding subtle changes to things, and we're just kind of like checking that things are exactly as they're expected to be. And then this is just using this quote representation, what we've seen before. So this is our successful quote, which was on the slide. We also have other things like a referred quote. So a referred quote is an applicant with a nationality of US. And then we've got also a declined quote, which is just somebody who's not old enough. So somebody who's 10 days old also gets declined. And then our harnesses, what we're using are here. So this one use up a MongoDB harness and a bureau data harness. The bureau one you've seen on the slide, which actually has the methods of add good bureau data and bad bureau data. And then the Mongo one is just going to grab pretty much just goes and gets the Mongo client out the database, or the database, gets the Mongo database out the IOC container and just goes and queries that document out of the collection. So it kind of just encapsulate that. So if we're doing that multiple times, it's just in one place. And if you've got any other kind of like queries or kind of things where you're going to insert to the database or change, they're just encapsulated in one place. And then this just has the posting the quote endpoint here. So the thing like the quote URL and what we're posting technically across the wire. But that's pretty much it. That's how the functional tests are kind of usually stuck together. So.
Sorry, Kevin, can we see it running?
Can you see it running?
Yeah, okay, so can we see all the tests run? Like?
Yeah. You can see the tests run. They do run.
Just see the testers.
Yeah. I did run them before, actually, before the presentation. So yeah, they all run. And to be fair, like, they're super fast, like pretty much done in.
Is this set up to a MongoDB database?
Yeah. So this is running Mongo. So in the background, this is running a .compose script, which is running the Mongo instance. So it's actually running the physical database on my local machine.
Okay, so do you have to like use like spring up the database?
Yeah.
And then run the test.
Yeah. So this is just so the database is not running now, but this has just got a compose script and it just runs the database.
Is there a way to do like a Docker command and just say like, hit this command, it creates a database and then runs a test, and then once the test is done, it destroys the database?
Yeah. So you can use things like test containers to do that, or you can use Aspire to do that as well. So they're like more code first ones. As at my current job and previously, I've just pretty much used Compose. Most because it's fairly simple and you can just wrap it into like any kind of solution. You don't really need like if you're using .NET Aspire, you have to pull in like a distributed application and then wire up all your dependencies inside that, and it plumbs all the configuration to it. The same as the test container as well. You also need to kind of do that as well with that. But if you just use .compose, then you can just point it to the local host and it just runs. Okay. So this has just got like a simple compose file, which is what this is running. And then these tests are just hitting that database. And I think it might have that in the, let me go back to this.
Because if I develop locally, it's probably easier to have that database in the background, like in Docker, and then run the test, like .NET test.
Yeah. You could just run a .NET test. So that's pretty much the same. Yeah, running it here is the same as just running .NET test, to be fair. It doesn't make any difference. So yeah, so like people always complain about these like taking a long time. And that one where the database wasn't running straight away afterwards, it's taking 1 second and 23 milliseconds to run the whole test suite things. So that's actually starting the server up at the same time, tearing it down, starting up, tearing it down, starting up, tearing it down, and putting stuff in the database, etc. So they're super slick and fast. And when people come usually complain that they're slow, it's because they've got something else problematic like in your code where maybe your execution path is doing something crazy like iterating over something a billion times, or got some sleeps in there, or you've not got an index on something in the database which needs an index on. So you're just highlighting a problem before you go to production, really. Okay, let's get back to the slides. So I've got a few other things to talk about. So that is unit tests. So for me, like as I said, unit tests are just pretty much a test around a single function or multiple functions. For me, it's normally multiple functions, to be fair. Normally a single function is just not enough like kind of behavior to test. But these are also run on the build server and every single commit as well when we push the build server. And I personally only use these for really complex logic, right? So maybe you've got some scorecarding within our like insurance API of how we kind of make sure that somebody is okay to give like an insurance quote to and not decline them. So we've got some really detailed testing based on like a scorecard, for example. And them kind of like tests are usually from them having too many permutations at high level as well. So you probably don't want to go through like every possible age on the NAPI. You want to probably like drill that down into like kind of more of a unit test. And usually like these are pure functions. So again, like I don't really want to use mock to mock everything out. And if I've got some dependencies for like my tests, I just want to plumb them in. So the given input gets the exactly the same given output. I don't want to have a given input based on this random mock, what I inject in, gets also random outputs based on the mock and the inputs. So I want to be very precise of kind of the behavior of kind of what I'm testing. So I've also got some examples of that in here. So as I said, we've got like in our code, in this quote. So after we get our, after we create our quote and it's okay, and we get our bureau data, and our bureau data comes back from the service okay as well, we go calculate our quote. And this calculate quote pretty much determines if we've been accepted, referred, or declined for that insurance quote. And it goes to this calculator to determine that. And this calculator is just pretty much a pure function. So it's just a static on a static class. So it actually has nothing else depending on it. And the things where it takes in is like today, the applicant, and the credit score. And even the today gets passed up all the way from this method. So even though this comes from the .NET time provider, we pass that all the way down the actual the stack. So we don't actually go to the time provider and have to depend on that within my class. I can just use it as a static class. Which means like my testing around the score calculator is usually quite simple. So similar to like the harnesses, I usually declare some stuff at the top, which is like some known state, like today's date, which is not today's date, it's just like a mocked out today's date. The applicant data, so we've got like what an approved applicant looks like. So approved applicant is somebody who's 30 years old and from the UK. And approved credit score. So similar to before, we've got like some kind of known data which we can share between our tests. And then we can just go call the calculate method on the scorecard calculator, pass in the today, pass in the approved applicant, pass in the approved credit score, and we should say this returns back our result of approved with what that should be set to. And then we can start doing the same thing, saying like should decline underage applicant. So we can then set up a bunch of data with different years, months, and days. We can then create the date of birth from it, get the approved applicant, like similar to like our approved quote, and just modify that single property on it. So you can say, go set the date of birth to what an underage applicant looks like. Pass it to the calculator and we get a decline result. The same thing for if they got a credit score less than 500, we can just pass that in with a bunch of different variables in there and then get declined out of it. And then also, for things which are non-UK, we should be referred. So we can go get approved applicant again, change its nationality, and then expect a referred result back out of it. So it makes the test like super slick, easy to read, and quite easy to understand. So that's unit testing. And then the last one is N10 testing. That's the flow of the whole kind of system. And I don't have any code to kind of show for this because you can do it, depending on your system, you maybe have like some front end which you use like Selenium maybe, I don't know, or Cypress or whatever the cool framework these days is.
How Blazor, can you do end-to-end test with Blazor, which is within your C#?
Yeah, there's like testing frameworks for Blazor as well to do end-to-end testing where you can spin up the whole component stack and test it end-to-end. But this might just not be like just one single application, like a Blazor application. The Blazor application might talk to some API, which talks to another API, which then sends a message to a message bus, and then sends an email, and does some big, massive flow of something. So if you're thinking about like maybe a e-commerce website, they might be adding products to a basket, checking the basket out, paying for the basket, making sure something's shipped, checking the shipping status as like a big flow through the system to make sure like that behavior is always kind of working. So these aren't really run on every commit to the build server. They usually run every single time we've deployed to the environment. And they're also really good for testing the infrastructure is all wired together, up and working. So if you're doing like infrastructure as code changes, maybe you're changing like the size of like your container instance on Azure Container Apps, and you want to make sure that's still working, you can just run these tests and you can know that like your system's actually up. So these are kind of less testing the behavior application, but more of the flows through the application. Maybe you got like a few happy paths, few sad paths, etc. But yeah, they're normally like multiple calls to APIs, maybe clicking on some pages, depending on what system you've got. And yeah, but that kind of like covers like an extra bit of testing, which your functional tests and your unit tests aren't covering to give you that confidence. But that's pretty much it. So as I said, it's all about confidence. So maybe you've got some different layers of testing in place for like different things, but these are the ones where I kind of start at. I've worked on like mobile phone applications as well before, where we've had a different test setup. So we've kind of mocked certain things out in the actual mobile phone app, and then tested them in isolation. So we've got like a nice boundary to test them in isolation, but tested the other things end to end. Functional tests are really good for kind of testing the boundary of the service to make sure like all the logic is actually correct. But it also does mean that you need a good boundaries to your services. So actually some kind of bounded context, which actually makes sense to your business. And we try to use the real dependencies, encapsulate as much logic as possible so you're not kind of like spreading everything everywhere. Don't rely on mocking. Don't rely on serializers or deserializers. And try to isolate your tests as much. Unit tests are more for detailed testing on one like focused area. And then end-to-end testing of like high-level happy path scenarios when you deploy. But that's it. So yeah, thanks for listening.